Good day, everyone. You are welcome back to Idowu Math class. Before we go straight to the work of the day, let's have the solution to our previous assignments. I want to believe that all of you laid your hand on the assignments. Good, you are good people. Let's have question number 1. It's on the board already. Solve log x minus 8 base 3 plus log x base 3 equals 2. This is addition. Addition, we turn to multiplication. So you have log x minus 8 times x equals 2 log 3 base 3. The reason why I use this format, I may choose not to use it, but I want you to be very versatile with all the approaches we have. Log 3 base 3 is 1. 1 times 2 is 2. It's like I don't change anything there. But it's a method on its own. So this is log x into x minus 8 base 3 equals log 3 square base 3. Remember, once you have equal bases in logarithmic equation, when you have equal bases on different sides of the equation that has only 2 terms and 1 term on each side, so the logarithm number will be equal to 1 to each other as well. Since base here is equal to the base here, automatically the number of the logarithm here is equal to the number of the logarithm here. And the number of the logarithm here is x into x minus 8, while the number of the logarithm there is 3 raised to power 2. So open this bracket, you have x squared minus 8x, which is equal to 9. 3 squared is 9. X squared minus 8x minus 9 equals 0. This is quadratic equation for you to solve. So solving this quadratic equation, we have x squared minus 9x plus x. Minus 9x plus x gives minus 8x. And minus 9x times positive x gives minus 9, negative 9x squared. So minus 9 equals 0. The HCF between these first 2 terms is x. X into x minus 9 plus 1 into x minus 9. I don't dwell on the solution of this quadratic equation because I've already taught you quadratic equation and we dealt with it seriously. So I'm only passing by. X plus 1 into x minus 9 equals 0. I conclude it on this side. X plus 1 is equal to 0, or x minus 9 equals 0. X equals minus 1, or x equals 9. That is the end of the solution of that question 1. Let's move to question 2 quickly. Question number 2 of the assignment. Express y in terms of x in half log x minus 1 base y equals 2. There are different approaches you can apply here. But I want to divide both sides by half. If you divide both sides by half there, so you will have log x minus 1 base y divided by 2 divided by half. This is what I say. I'm dividing both sides by half. The half here, we cancel the half here. The half here is what I put to the side. You understand? So log x minus 1 base y is now equal to 4. When you divide 2 by half, you get 4. You understand? That is 2 times 2. That is it. 2 divided by half is 4. So at this juncture, you have x minus 1 equals y raised to power 4. This is a way of writing the logarithmic function in indices format. You have this. But we are to make y the subject of the formula. That's the meaning of the word express y. Express y in terms of x, meaning that you have to make y subject of the formula. If you are making y subject of the formula, it's a topic I will still teach you. But now that it comes by the way in this, let's deal with it. You just solve it normally as normal indices. Y times 1 over 4 equals x minus 1 raised to power 1 times 1 over 4. What are we saying? You want to find the value of y, multiply the powers on both sides by the reciprocal of the power of that y. The power of y here is 4. The reciprocal of 4 is 1 over 4. Use that 1 over 4 to multiply the powers on both sides. So this, we cut this. We have y equals x minus 1 in bracket raised to power 1 over 4. This is a good answer. And if you want to leave it in root form, right, or fourth root of x minus 1. So either this way or this way, you are good. So let's move to question number 3. Question number 3. This is the end of this question. Let's have the solution of question 3. Solve log x plus 8 minus log x minus 1 equals 1. Once you don't have a definite base written at the subscript of the log, it simply means that we are operating in base 10. So subtraction will turn to division as usual. So we have log x plus 8 all over x minus 1 base 10 equals log 10 base 10. Why do I write log 10 base 10 straight? 1 is the same thing as log 10 base 10. If it were base 3 we are using, I would have written in place of that 1, log 3 base 3. You understand? Just to form your 1 is an approach, and you can work with another approach, but I choose to use this. So now that we have equal base on different sides of the logarithmic equation, it simply means that their logarithm number also are equal, meaning that x plus 8 over x minus 1 is equal to 10. This 10 is the number of the logarithm here, while this also is the number of the logarithm here. They will be equal to each other so far these bases are equal. Do you understand? So 10 over 1 is the same thing as 10. Cross multiply, you have 10x minus 10 equals x plus 8. Collecting the like terms, you have 10x minus x equals 8 plus 10. I want to believe you understand what I'm doing. So this is 9x equals 18. Dividing both sides by 9, we have 9x divided by 9 equals 18 divided by 9. And finally, x is equal to 2. And that's the end of that. Let's have solution to question 4. Find x if log 2x base 3 plus log x plus 1.5 base 3 equals log 2 base 3. What do we do? This addition must change to multiplication. Don't forget. So we have log 2x into x plus 1.5 base 3 equals log 2 base 3. Equal bases on different sides of the equation implies equal number of logarithms. So the number of logarithm here is 2x into x plus 1.5. The number of logarithm there is 2. Opening the bracket, we have 2x squared plus 3x, which is equal to 2. Someone is confused. Okay, how do we have 2x times 1.5 equal 3x? This is it. 2x times 1.5 means 3 over 2. You understand? These two cut these two. X times 3 is 3x. So that is it. That's the opening of that bracket. Equals 2. So we have 2x squared plus 3x minus 2 equals 0. Quadratic equation. You can now see the reason for treating quadratic equation, linear equation, and the likes first when we started this class. So, because they are like tools that you will often meet on your way in mathematics. So, solving this quadratic equation, we have 2x squared plus 4x minus x plus 4x minus x gives plus 3x. And plus 4x times minus x gives minus 4x squared, which we have if we multiply this first term and last term together. 2x squared times minus 2 gives us minus 4x squared, which is the product of this if we multiply them together. So minus 2 equals 0. 2x is common here to give us x plus 2 minus 1 into x plus 2 equals 0. So 2x minus 1 into x plus 2 equals 0. If you find quadratic equation difficult, that means to grab everything about it. So you have to go back to your to whatever record you have to make sure you strengthen that knowledge of quadratic equation. So 2x minus 1 is equal to 0, or x plus 2 equals 0. Come to this side. Solving each linear equation, you have 2x equals 1, or x equals minus 2. X equals half, or minus 2. So that is the end of that. Let's have question 5. Solve log y squared minus 1 minus log 1 plus y equals 0. Obviously, we are dealing in base 10 here. So you have log y squared minus 1 divided by 1 plus y equals log 1 base 10. How? In logarithm, it is only log 1 base 10 that I have told you will give you 0. So, in the place of that 0, you are free to put log 1 base 10. Do you understand? So, and the base 10 is here as well. So far, we have equal bases on different sides of the equation. Their logarithm number also are the same. The logarithm number here is y squared minus 1 divided by 1 plus y. Why the logarithm number here is 1? So, looking at this, y squared minus 1 is difference of 2 squared. So, you simplify it as y minus 1 into y plus 1. We have dealt with this extensively under algebra. So, if you have forgotten something further there, refer to the clip that contains it. 1 plus y equals 1. This, we take care of this. Y plus 1 is the same thing as 1 plus y because of the rule of commutativity. So y minus 1 is equal to 1. So y equals 1 plus 1. Y equals 2. That is the end of that question. Let's go to the last question for the assignment. Let's solve the last question of the assignment. If log m minus 3 is equal to log 3m plus 5, find m. You can see we are operating in base 10. So, you can rewrite as m minus 3 base 10 equals log 3m plus 5 base 10. Rewriting it does not make any difference. It's only for you to be, to pay attention to what you are doing. Now that you can see visibly that we are having equal base. So you know that their number of logarithm also must be equal. So you say therefore m minus 3 equals 3m plus 5. Do you understand? Collecting the like terms, you have m minus 3m equals 5 plus 3. Taking positive 3m from this side to the other side, it changes to negative 3m. And negative 3 here changes to positive 3 on crossing the equal sign. So here we have minus 2m equals positive 8. Dividing both sides by negative 2, we have negative 2m divided by negative 2 equals 8 divided by negative 2. So m equals negative 4. And that is the end of that.